Hello, and welcome to the first of a series of video tutorials exploring the new features of FORCinel 3. My name is Richard Harrison, author of FORCinel, and throughout this series I'll be guiding you through the process of loading, processing and analysing fault diagrams and showing you how to get the best out of the software. In this first video I'll be taking you on a quick tour of some of the major new features in FORCinel 3. Version 3 represents a major update to FORCinel. Virtually every aspect of the software has been written or rewritten from scratch, making FORCinel 3 dramatically faster, more powerful and much easier to use than ever before. The first thing you'll notice is a dramatically improved workflow for loading, pre-treating and processing your fork data. Most of these operations are now controlled directly from the fork control panel, which can be set up to automatically apply data pre-treatments such as drift correction, first point artifact removal, and lower branch subtraction whenever new data is loaded. These pre-treatments can be switched on or off or adjusted at any time, allowing you to interactively explore the effect of different data pre-treatments on your processed fork diagram. FORCinel 3 is much faster, especially when handling large datasets. It's been written to take advantage of multiple processors where available, combined with the ability to vary the output resolution of the processed fork diagram. This means that very large fork datasets, such as those containing 500 or more fork curves, can be processed in a matter of seconds, whereas previously this may have taken more than an hour to achieve. The faster processing means that smoothing factors for large datasets can be optimized much more efficiently before the final high-resolution output is created. There's now a unified approach to smoothing in FORCinel, and you can easily switch between classic constant smoothing factor approaches or the more advanced VariFork approach through the click of this simple smooth checkbox. There's no more switching between different data folders containing data that has been processed in different ways. Version 3 now has the ability to load, process and analyze multiple fork diagrams at once. Almost every function is now aware of multiple selections in the data browser and will automatically apply whichever function you choose to all of the data that has been selected. This allows differences between fork diagrams from different samples to be compared easily, or multiple measurements of the same sample to be loaded and averaged to increase the signal to noise of weak samples. As well as loading standard PMC files, both with and without hysteresis loop included, a new function to load generic fork data has been added. This makes it much easier for data recorded on non-PMC systems to be loaded into FORCinel and gets rid of the need to create fake headers and fake drift data. An example of the generic file format is included in the FORCinel download package. This option can also be used to load PMC extended fork files. FORCinel 3 is also able to process data collected using non-uniform field steps. The editing and optimization of color scales has been made much easier and more intuitive in version 3 with the addition of an interactive non-linear color scale editor that allows you to choose specific colors and to move the transition points from one color to another in real time. A major new addition is the integration of FORCinel with FORCum, a new method to identify and quantify the different end-member contributions to a fork signal using principal component analysis. This method is proving to be an extremely powerful way to extract environmental magnetic signals from sediments and soils, but is equally applicable to providing a quantitative breakdown of the different domain state contributions in igneous rocks and meteorites. A separate video in this series will be dedicated to demonstrating how FORCum can be used to perform this analysis. FORCinel has also been integrated with FORCulator, a powerful way to calculate fork diagrams for arbitrary ensembles of interacting single domain grains. And again, a separate video will be dedicated to demonstrating the features of FORCulator. There are many other new and updated features in FORCinel 3, and these will all be covered in separate videos, so please visit the nanopaleomagnetism website If you have a request for a specific tutorial on any aspect of FORCinel, then please get in touch and put in a request.